Students, let us solve this Irodov problem 1.27. This is a very tricky question. A particle moves in the plane xy with constant acceleration w directed along the negative y axis. Okay. What is given that the acceleration of particle is only directed in negative y direction. It means that the acceleration in x direction should be 0 and the equation of motion of the particle has the form y equal to ax minus bx square, where a and b are positive constants. Find the velocity of particle at the origin of coordinate. So this is the general equation y equal to ax minus bx square, and I have to calculate velocity but not at a random point, at the origin. So origin means x is 0 and y equal to 0. How to do that? Let me differentiate this equation with respect to time. So the given equation is y equal to ax minus bx square. If I differentiate, it means this is dy by dt should be equal to a is a constant, so a into dx by dt minus b is a constant and differentiation of x square is 2x into dx by dt. Okay, what is dy by dt? This is the velocity of particle in y direction. So I write it as velocity of particle in y direction should be equal to a into, what is this? Velocity of particle in x direction. So a into vx minus 2bx into, what is this? This is velocity of particle in x direction. Okay, so this is the point. Now I have to calculate velocity. I have to calculate velocity at origin. At origin means when x is 0 and y is 0. So let me put x is 0 and y is 0. There is no y, but there is a x. So when x is 0, this part will become 0. So at origin, I get a number vy must be equal to a into vx. At origin, vy should be equal to a into vx because when I put x 0, this part is 0. Okay. Now, to use the information of acceleration, I further differentiate this equation with respect to time. So, dvy by dt should be equal to a into differentiation of this dvx by dt minus one more point is that acceleration of particle in x direction is 0. It means that velocity of particle in x direction must be constant, because there is no acceleration in x direction, so the velocity in x direction must be constant. So this is not a variable. This is not a variable. So let me use this concept. Vx is not a variable, Vx is a constant. So differentiation of a constant is always 0. So dvy by dt should be, this part is constant, so differentiation of this part is 0 minus this part is constant, so 2b vx is a constant, and differentiation, this is variable, so differentiation of x is dx by dt. So acceleration in y direction should be equal to minus 2b, this is also vx, to be vx square. So acceleration in y direction should be equal to minus 2b vx square. And in question it is given that acceleration is w. So w equal to minus w equal to minus 2b Vx square. It means that Vx square is w divided by 2b. So velocity I get in x direction, and which is always constant. So Vx square is equal to w divided by 2b. W divided by 2b. Now let me use this equation. So what is the Vy square? So Vy square should be equal to a square into Vx. So a square omega divided by 2b. A square omega divided by 2b. Now I have to calculate velocity of particle at origin. So velocity should be equal to root of this part under root w divided by 2b I cap and root of this part plus under root a square w divided by 2b j cap. This is velocity of particle at origin. What is the magnitude of this velocity? Means speed. What is the speed? So a speed should be equal to a square this of this plus a square of this under root Vx square plus Vy square. So it should be equal to under root, what is Vx? Omega by 2b. What is Vy? A square omega divided by 2b. So it should be equal to 1 plus a square divided by 2b into omega root. So the magnitude of velocity at origin is this, and in vector form this is the answer.